Welcome to the channel. So in this video we will talk about how we can find the wave function and what are the criteria for a acceptable wave function. So to start it, we can start from how electron propagate, like how let's suppose if we have a starting point and a final point, right? And the starting point is particularly this and final point is this. So how an electron could go from here and reaches there? So basically it can follow all the possible path. Electron propagate through all possible path. What are the possible path? Example, electron can follow this path, right? And this trajectory. Or electron can follow this particular path, let's suppose, right? Or electron can follow this particular path, and so on. So there can be infinite possibilities and there are infinite paths. So all the possible path an electron can follow. So if we want to find out the probability to finding an electron, so probability, as you know, is directly proportional to the wave function square, right? But this psi should be total. How we can find the total psi? The total psi would be equals to the wave function associated to each path and its sum, and so on. But how I could able to find out this psi? So to find out a particular psi, we need to assume a particular path which can electron follow. Let's suppose if we can assume the path of electron, then with a particular time we could able to uh, find its position from this equation, right? Let's suppose this is the equation which electron would follow. This equation is associated to a particular path, and if we could able to find out this equation and find out the position after a particular time, we could able to find out the velocity, right? And if I could able to find out the velocity, then we can definitely find out the kinetic energy and then potential energy. So the term action is denoted by capital S, and this action is basically the integration with respect to time from time t1 to t2 by multiplying it with the difference of kinetic energy and potential energy associated to a particular path. So if we could able to find out the action associated to a particular path, then we could even find out the contribution of a path, and the contribution of a path is basically equals to e to the power iota s by h cross, and you know h cross is basically equals to h upon 2 pi. So if I could able to find out the contribution of a particular path, then you know that the total psi would be equals to sum of the contribution of each path. By doing this, we could able to see a particular constant, and I am denoting it by capital N. This constant is called as normalization constant. and we will learn about it in future. Okay, let's suppose we could able to find out the psi. Does the psi which we have founded is acceptable? So what is the criteria of acceptable wave function? So there are many criteria, and one of the important criteria are the wave function should be real. It should be a real wave function, right? And single valued. The next criteria is it should be continuous. And the third one is it should be square integrable. Okay, so we'll start from what is the meaning of wave function which is single valued wave function. Okay, let's suppose for example we have two type of function. If I just able to plot it with respect to time, and let's suppose it is psi, and again an example is this. Okay, so the very first function could look like this. Let's suppose we have this kind of function, right? And the other function is this. So which one would be acceptable for us? The very first one, this one is not acceptable for us because at a particular time we can have many values of this function. It means at a particular time the electron could be anywhere, it can have any amplitude, so it should not be true, right? Because at a particular time it should have a single value, so we cannot follow this function, right? This should be acceptable because at each particular time the function look different, and we could able to try to find out the possibilities and the probability of function of electron. The next is it should be continuous wave function. It means it should not be discontinuous. What it means, let's suppose if we have example the path followed by electron, or the wave function look like this. Let's suppose one of the wave function is this is the value 0, and this is negative value, and this is, let's say, positive value. Okay, so let's suppose if I approaches from negative side to 0, slowly the function is increasing and reaches 1 at 0. But if the same function I approach from the positive side to 0, in starting it increases and find its peak, and when it just starting reaching 0, it basically shuts down or becomes 0. Not like this, wait, it could look like this. So this type of function is not acceptable for us, because this is a kind of discontinuous function, right? It does not have a continuous values. our wave function should or could look like this, right? Everywhere it is continuous, there is no discontinuity or no discontinuity. Okay, so and the next thing which we need to talk is square integrable. Okay, so see, let's suppose we have a psi, and if I integrate that psi uh, with the its complex conjugate and multiplied with the volume element, that's what d tau. D tau is volume element. For 1D or one dimension, that d tau can be, let's suppose, dx, or for two dimension it can be dx into dy, and for three dimension it can be dx into dy into dz, right? So what is this? Basically, the psi star and psi, this whole thing is probability density. Probability density. The probability density is basically the probability of finding electron at a particular point or a unit volume, and we multiply it with, if with a volume element or the whole volume, it will give us probability to finding electron throughout a volume from minus infinity to infinity. Let's suppose this whole volume, right? So if I suppose that our electron, if our electron is present in a particular system, then this value, probability, should be equals to 1, because we have assumed that our electron is there. But if it is not equals to 1, then what we can find, what we can do? For example, let's suppose I have a psi, and the value comes is like this. Let's go psi star into psi d tau would be equals to 10. It can be 10, but our wave function have to show the probability of 1. It cannot be 10, right? So in such condition, what we can do, we can basically divide the whole thing with 10, then it would look like this, right? And this value will become 1 only if we multiply our psi with root over this, right? And this constant which comes so that our probability become 1, this constant is called as normalization constant. This constant is called as normalization constant. And one case can come is that, let's suppose if this value is equals to infinity, like this cannot be possible. If this value become infinity, then psi should be 0, and this is a meaningless term, right? This is meaningless. Why? Because if we assume that the electron is present in a particular volume, then we could able to find out the psi, and it should not be zero, right? So this is the whole thing which we have talked about in this video, and in the next video we will start about the postulates of quantum chemistry. Thank you for watching the video.